Welcome to your future. Welcome to Vision Academy. Let us unlock your full potential.
Shortcut works across 3 specific levels of difficulty. We are going to walk through them one by one, starting with the simplest repeating numbers and building up to the hardest mixed decimals. By the time we finish the 3rd step, you will be able to look at almost any bar question and identify the numbers you need to reach a final fraction in seconds. Let's start with step 1, pure repeating decimals. This is the simplest level, where every single digit after the decimal point has a line or a bar over it. Here is the core rule. Look at 0.5 repeating. To turn this into a fraction, take the number under the bar and write it as your numerator. Then, for the denominator, simply write a 9 for every digit under that bar. This rule scales as numbers get larger. For 0.79 repeating, move the 79 up to the numerator. Since there are 2 digits under the bar, place 2 9s in the denominator. That gives you 79 over 99. The exact same logic applies to a 3-digit number, like 0.123 repeating. The 123 becomes your numerator, and because there are 3 repeating digits, you write 3 9s below it, giving you 123 over 999. Now, there is a common trap on multiple choice tests. Let's look at 0.3 repeating. The rule gives us 3 over 9, but you might not see that in your options. You always have to check if the fraction can be simplified. Dividing both numbers by 3 reduces it down to 1 over 3, which is the final answer. When you see a denominator made entirely of 9s, you know you are dealing with a purely repeating decimal. It serves as a reliable indicator that the conversion is correct. That brings us to step 2, mixed repeating decimals. This is where things require a little more care because only some of the numbers after the decimal point repeat. Look at 0.47, where only the 7th has a bar. We need a new numerator rule. First, write down the entire number, 47. Then, subtract the digit without a bar, the 4. That gives a numerator of 43. For the denominator, combine rules with a new step. Write a 9 for every repeating digit and a 0 for every non-repeating digit. 1 repeating digit gets a 9. 1 non-repeating gets a 0. The fraction is 43 over 90. Let's apply this logic to a larger mixed decimal, 0.235, where only the 35 repeats. To find the numerator, take the entire number, 235, and subtract the non-repeating 2. We get a numerator of 233. To finish it out, we map our 9s and 0s to the denominator. We have 2 repeating digits, so we write 2 9s. We have 1 non-repeating digit, so we write 1 0. The result is 233 over 990. The most common mistake here is forgetting the subtraction in the numerator. Always remember to subtract that non-bar number from the total before you finish the problem. Seeing a mix of 9s and 0s in the denominator tells you that the original decimal was mixed. This pattern makes it easy to identify the decimal type just by looking at the resulting fraction. Finally, step 3 covers the hardest variation. What to do when the number before the decimal point is greater than 0. Look at 1.5 repeating. Isolate that 1, treating it as the whole number. Next, apply the first rule to the 0.5 repeating. It becomes 5 over 9. Dock that next to the 1 to create the mixed fraction, 1 and 5 ninths. Now we convert this into an improper fraction. Multiply the denominator, 9, by the whole number, 1, and add the numerator, 5. Your final answer is 14 over 9. Let's combine everything for a problem with a whole number and a mixed repeating decimal, 4.12, where only the 2 repeats. We start by separating that 4 to the left side. Apply the mixed decimal rows to the 0.12 portion. Take 12, subtract the non-repeating 1, getting a numerator of 11. 1 repeating digit gets a 9, and 1 non-repeating gets a 0. The 11 over 90 docks next to our 4. To finish, multiply it out. 90 times 4 is 360, plus 11 gives us 371. The final result is the improper fraction 371 over 90. Arriving at an improper fraction where the top is heavier than the bottom shows you've successfully accounted for the whole number. If you can reach this point, you have a handle on the toughest version of the bar question. By using these rules, you can solve these problems by identifying the component parts rather than navigating the algebra. It replaces a long process with a targeted sequence of steps. Let's review the framework. Pure repeating decimals use nines. Mixed repeating decimals.
Like this video? Subscribe to our channel. Share this video. Thank you. Shukriya.